All right. Welcome back, everyone. Gorky and Emmanuel, are we good to go out? Or do you want me for...
Yes.
Okay, all right. I will share my screen. Please bear with us till we fix the issue of the screen being tilted a bit. But I think so. You have practice from the ASHRAE 170 standard where we had the tables tilted and we were tilting our head to check what is going on. All right, so welcome to the folks online as well. We are getting started. Give me just a moment till I share my screen with you and get my model opened as well. All right, so we are on the final stretch now. We gotta hit the home run. Lot of knowledge that we have digested and applied over the past 4 days, and this is like the final stretch for hitting our home run. All right, so now yesterday we had focused on getting the power devices placed, right now we need to make sure that the power devices that are placed are properly circuited to their panel boards. Correct? At the end of the day, the power for these outlets will come from a panel board. All right. For that, what I want you to do is go into the family section over here, right? In the family section, you will have electrical equipment over here. All right. For the folks online, please give me a confirmation that you can see my screen. So in the families option over here, yesterday we had spoken about the annotation symbol for the lighting tags. We had checked the data outlets, right? We had also checked the junction boxes, duplex, simplex receptacles. What I want you to do is open up the electrical equipment family tree. Thank you for the confirmation, Grace. In here, what you will see is different type of panel boards over here. All right. What I want you to do is open up the lighting and appliance panel board 208 volt MLO. Right. Now, based on the loads that you will be calculating for a given, one more time. You want me to show this one more time? Okay, I'll take that as a no. But what we need to do is we need to have the conductor properly designed for our panel board, right? This is dependent on the demand load calculations that we spoke about yesterday, right? Connected load into diversity will give us the demand load, right? That will be in VA or kVA. Divide that by the voltage will give you the amperes, right? So for every type of area, there will be a dedicated panel. All right. So you can have a panel board assigned to one operating room. You can have panel board assigned to outlets for one floor general ward rooms, right? Then the outlets for private rooms, you can club it differently. Making sense? So now for that reason, what we are going to do is we are going to give this surgery room its own panel board of 100 amps. Okay. So you have 100A over here. Simply click, hold, drag and mount it on this wall over here. Okay. Click, hold, drag and mount it over here. Okay. This is happening because some of our visibility graphics that we spoke about might not be properly assigned. Okay. So what I want you to do is do some investigation. So first of all, this is the error that you might get, right? So in that case, first we will check what the visibility graphics are set. Okay. For that, we will check if any view template is set. If the view template is set, then you need to go to the view template and try to change the information in the view template. But since view template is not set, we will go to the visibility graphics. Yesterday we had discussed regarding the shortcut, keyboard shortcut for visibility graphics. What was it? If anyone remembers, VV. Hit VV on your keyboard and try to locate the electrical fixture, electrical equipment, if that is turned on or not. Over here, is it turned on? Yes, right? Okay. So there might be some other reason why the panel board is not showing up. Okay. Now we will investigate why it is not showing up. First, we'll take a section view and try to find the panel board over here in this. All right. We'll adjust the view extents over here and we'll go to that section view. All right. Now, if you see over here, there is a panel board over here. Okay. Now this panel board is mounted on the floor. Panel boards are never mounted on the floor, right? They're mounted on the wall. So can someone tell me what I did wrong over here that it got mounted on the floor? Exactly. Vertical face, right? Now, what I'll do is, I still have the panel board selected, okay, over here. I go to the floor plan over here, and in here, placement, I can pick new. In the work plane, I can pick new. That will again give me an option for placement. Right now, it is mounted on the work plane. I think so. The work plane over here, I had selected as level 1. But I need to have it on a vertical face. Now, if I try to check, this is a recessed panel, right? It is in the wall. It is a recessed panel. If I hit space, it will become a surface panel. It is outside the wall, mounted outside the surface of the wall, right? Now, different type of locations would require different types of panel boards. In case aesthetic drives the factor of your room, you might want to have it in the wall recessed. But if you have a dedicated room for the panel boards, you can even mount it on the surface. All right. Now we can click over here and our panel board is mounted, but again, it is mounted at 0 foot. If you go to the section, it's still not up in an elevation. All right. Again, panel boards are usually meant to be at approachable height, right? That if the electrician needs to work on the panel board, it is approachable for them. The circuits in there are approachable for them. All right. For that, we will increase the elevation from the host to 4 feet. All right. So simply go over here, elevation from the host. Let's make it 4 foot. And hit apply over here. The panel board is now raised to 4 feet. Everyone with me till now? No? All right. Yes or no? No. Okay. All right. So first of all, did everyone understand why the panel board went to the level 1? Why was it mounted on the floor? Yes? All right. Now over here, even if I selected the new placement on vertical wall, the level from the host was still assigned to that level 1, which is 0, which is on the floor, right? But we don't want that, right? We want our panel boards to be at approachable height, right? Because when an electrician is working, electrician will avoid trying to have to stretch their hand, because again, it is a life safety thing that they are trying to work with electricity power, right? So it would be better for them to have it at an accessible height. 4 feet, all right? In case there is some other requirement, right? If it needs to be above the ceiling, sometimes they tend to be above the ceiling because space is a restriction. If it is above the ceiling, please make sure that there is enough clearance, minimum 3 feet in front of that panel board for the electrician to actually work on that panel. Does that make sense? Sure? All right. Okay. You place the panel board on face. That is correct. Yes. Peter, it is VV, not VG. The shortcut to the visibility graphics is VV. All right. So now we have our first panel board mounted on the wall. Now we'll go back to our power plant. Okay. Now again, going back to our notes yesterday, there are two types of power sources in a given operating room, right? What is the first one? UPS, and second one is the utility, right? So now both of these power sources require their own panel. Okay. So right now, if you check this one, you can label it with the panel name over here. Okay. In the properties, you can name it with the panel name. Okay. So every facility might have a different standard. They might classify it as high voltage, low voltage, as per the floor, as per the power utilization, like is it going for a receptacle, lighting, any specialty equipment, so on and so forth. All right. For this panel, what we will do is we will label it as OR, that is operating room, the panel name as OR, and we'll just call it 1 because it is the first panel board series in the OR, right? And then what we will do is we'll also add a UPS. So basically this is the panel board, the first panel board that is assigned to this OR, and it will get its power from the UPS. Are you with me till now? Okay. Now, what we are going to do is we are going to connect every alternate. Yesterday we had 6 on this wall, 6 on this wall, and 4 on this wall. Correct? Simplex receptacles. What we will do is every alternate one. So 3 on this wall, 3 on this wall, and 2 on this wall. Simplex receptacle, we will circuit it to this panel board. All right. For that, what I want you to do is click on that particular simplex receptacle. Then go to power over here that comes in the modifier ribbon. When it comes to power, now it is asking us select the particular panel board. We want the simplex receptacle to be connected to this panel board. All right. You can either simply click on it. All right. Just let it get. No. Undo. Over here, power. You can click on select panel and then click on this panel. Now this particular simplex is connected to this panel board. All right. Or second way of doing this is click on the simplex, go to power, and over here, okay, so just okay. Click on the simplex, click on power, and in here, what is going on? So click on simplex. Oh, just. So it was OR1 UPS, right? So click on the simplex, then go to the power, and in the electrical circuit, you can simply drop down the box. If you have multiple panel boards, you can drop down the box and select that panel board. Now I'll show you how the other panel board that will run on the utility power will look like. Okay. So we'll bring this another panel board with 100 amps for the other 8 receptacles that we have mounted. Okay. This one is the UPS panel board. All right. This one will be the utility panel. Over here, we'll change the name. Again, it is an OR1 and let's call it as UTI for utility panel board. All right. So this one is OR UPS. And this one is OR utility. Okay. Now, if I go and try to circuit the second one, go to power. Now over here, if I drop down the box, I'll see 2 panel boards over here. Revit is giving me option now. Which panel do you want to connect it? Do you want to connect it to the UPS panel or UTI panel? Let's say you have 100 panel boards on your project. It will not be feasible to click on select panel at that time you can use it. Does that make sense? Yes. Is everyone with me till now? Please make sure you understand this concept of proper circuiting. Right? Is everyone with me till now? Back over there. I'll show again. Alright, one more time. So I'll undo everything over here. Okay. So there are no panel boards. We'll have 2 panel boards assigned to this operating theater. One will be connected to the utility power. The second will be connected to UPS. All right. It will be all 100 amps, assuming that we have done all the calculation. All right. With the connected load into diversity equals to demand load for the utility panel. For the UPS panel, connected load equals to the demand load. No diversity on that. 100 amps, click, hold, drag and move it. Over here, make sure in the modify placement, place on vertical face. Okay. Now go in there and hit tab, hit space to make sure you have a surface mount panel board. Place another panel board. So now you have 2 panel boards. One will be utility. Second one will be the UPS. How to name it? Click on the panel. Scroll down over here until you come to the general section. Under the general section, you have the panel name. In here, you can put your panel board name. First panel, OR, operating room 1 UPS. OR 1 UPS. Second one, OR 1 UTI for utility. Now everyone with me till now? Now, what I want you to do is, first receptacle from the door, all right, from the door latch, if you want to be more specific. First receptacle from the door latch, click on it, click on power on the modifier ribbon, and over here you can drop down the box and select UPS. So now your first outlet is circuited to this particular panel. Again, I'll show the adjacent receptacle. Click on the receptacle. This receptacle we will connect it to the UTI panel, the utility panel. All right. You click on the receptacle. You go to power under the modify ribbon. Click on it. It will give you the option for the system settings over. In the system settings, you can either if you have multiple options, you can pick which one it is, but we know this particular receptacle, we want to connect it to the UTI panel. Right now, Revit defaulted it to the UPS panel because the previous one, we had circuited it to the UPS panel. All right. Now Once we click UTI, now this particular device is connected to this particular panel. This particular device is connected to this particular panel. I'll show one more time. I'll show it on the third receptacle. All right. We have selected the receptacle. Power. Now this was UPS. This was utility. This is UPS again. I've selected that particular simplex. Went to power. In the system tools, we need to make sure that we are connecting it to the UPS, because every alternate UPS. Now then you will leave one more and the next one will be UPS. Is that making sense? Is everyone following with me? We are not getting naming. Okay. Click on the panel board. You will have properties over here. Scroll down. In the general, you will have panel name row over here. In that panel name row, you can enter the panel board name. Online, is everyone following? AC or fan over here? Getting too hot. No AC or fan or all. Does anyone need help? Please call me to your desk, please. Today the room structure is a bit different. Back over there. Okay, let's move forward with the next concept for the panel board schedules. Now we have two panels. Please note, for making sure that we use panel board schedules, we need to have panel boards placed on our, can I have your attention? Please. Hello. We need to have panel boards placed on our floor plan. For that, what we will do is, we will click on the panel board. And when we click on the panel board, in the modify electrical equipment, you will see create panel schedules. Click on the panel board. Click on the panel board. And then you will see create panel schedules over here. Click on the panel board, drop down the box, create panel schedules. Is everyone with me till now? Okay. After that, click on choose a template. Okay. So now you have different templates that Revit already feeds into the template itself. That systems template.rte that we used will already have this information. Okay. So right now we can go ahead with branch panel. Okay. Branch panel and branch auto shading. We'll talk about auto shading in some time. But we can click on branch panel because it is the branch panel of the main switchboard that we are talking about. And then hit OK over here. Right? Once you hit OK, you will have your panel board schedule created. Does that make sense? And over here in the panel board schedule, you will already have your receptacle that was connected with a 20 amp breaker. That is one pole. And it's supposed to be 180 VA. Is everyone with me till now? Now, sir, you mentioned yesterday that in Rwanda, we consider 500 amperes maximum, 500 VA maximum for the outlet, right? Right now it is showing 180 for one outlet. We can change that as well. What we need to do is go to power, click on the simplex, go to edit type over here, and then change this load to 500. Okay. Please note, if you change this for 500, all of the simplexes throughout the project will become 500 watts or VA. Okay. Now, if I go back to the same panel board schedule, you see my load has changed to 500 VA. Right? 180 VA is an American standard, just like you have 500 watt standard. So 180 VA is something that comes from the National Electric Code of National Fire Protection Association, typically used in the North American continent. But this is basically where you can change the loads. All right. So now this is where we are getting the panel board schedule from. Yes. In the wall, flush to the wall. Yeah. Okay. Yeah. So the question in house was, you see that my panel boards are surface mount. What is a surface mount? That is mounted outside the wall. Okay. Something similar to, we have recessed lights, right? We have recessed lights that are flush with the ceiling. And then we have surface lights that get mounted on the ceiling. The one in the beam over there is a recessed. All right. But yesterday downstairs when we were seeing, those were all surface mount. All right. So what I need to do is to make it surface or recess, click, hold, drag, and when it shows on the wall, hit space on your keyboard. Yes. Space. All right. So over here, it took some other. Okay. Space. So when you come to your desired configuration, then click on the wall, it will be surface mount. Does that make sense? All right. So everyone got the concept of panel board schedule? Yes? All right. So now, any question for me? All right. So everyone with me till now? Okay. So now we have seen the concept of circuiting. We have seen the concept of panel board. We have seen the concept of panel board schedule. Okay. What we will do is, as a practice, we will also circuit the lighting fixtures. Lights also require power, right? So let's say the 4 or 5 light fixtures that we have in the given project. I select all of them, and then we can go to power. Grid systems. No. Let me take that back. Select on the one of the light fixtures. Same power will show up. And over here in the systems load, you can drop down the box and try to select which panel to select, circuit. All right. Again, all of the light fixtures in the operating rooms need to be circuited to UPS. All right. Now, we want only one circuit for the UPS. We don't want 4 circuits for the UPS. For doing that, what we will do is, we'll select this light fixture which is already circuited to a circuit. Once you select that, go to electrical circuit and then click on edit path over. Okay, let me take that back. Even I have not used this in quite some time. Okay, electrical circuit and edit circuit. All right. Once you edit circuit, it will give you options to add to circuit. All right. So rest of the 3 light fixtures, with your control button pressed on your laptop or on your keyboard, select rest of the particular light fixtures. Now, I'm getting an error over here. It is saying that that light fixture that we have is rated for 208 volt, but this particular light fixture is rated for 277. So this light fixture will not be circuited to the given panel because our panel is rated for 208 volts, right? So the reason I'm going through this is to make you understand that you need to have the proper voltages selected when doing the circuiting. Did it make sense? Okay. So now, sorry. Okay. So let me cancel this and go back. We had we decided yesterday that we require 4 light fixtures, correct? Based on the lux level, based on the foot candle levels, right? All of those 4 light fixtures, we want to connect it to only one circuit, right? We don't want 4 circuits to be occupied over here for 4 light fixtures. We just want one circuit for 4 light fixtures, right? So for that, we select and circuit the first light fixture. Okay, how we do it? Same way, click on the light fixture, click on power, and click on the UPS panel that we need. All right, now this particular light fixture is connected to the UPS panel. All right, now what I'll do is I'll click on that same light fixture again, go to electrical circuits, edit circuit, and then with the edit circuit activated, I'll click on add to circuit. So I'm adding more light fixtures to that same circuit. That circuit will be the OR1 UPS panel. All right. And then with your control button pressed, select the light fixture. So now these 2 light fixtures are on the same circuit. All right. Now, yesterday I was trying to explain you the difference between the tags of 2 different light fixtures, the A and B, right? In that process, I had selected 2 other light fixtures that were of other voltages, namely 277. All right. These 2 were of 208, but these 2 were of 277. Our panel board, if you check properly, is rated for 120/208 volts. Now, if I try to select that particular light fixture over here, it will give me a warning that this particular light fixture is rated for 277 volt and you're trying to connect it to a 208 volt panel. Since it is out of its working voltage, we cannot circuit these particular light fixtures to the 208 volt panel. Does that make sense? All. So I had placed the 277 yesterday, but all 4 of your model's light fixture is already on 208 volt. So you can go ahead and circuit it. Once you go ahead and circuit it, if you open the panel board, now you will see that the 64 VA, right? Yesterday we were checking the light fixture wattage. 64 VA is assigned to that particular lighting fixture or the lighting fixture circuit. Did it make sense till now? Yes. Switching, yes. So one more point is regarding switching. That's good. Okay, so one point in the room was regarding the switching of the light fixture. So the light fixtures get power indirectly from the switches, right? The switches come in series with the light fixtures. So if you turn off one switch, all the light fixtures will go off, right? In Revit, you can, yes, have a light fixture switch assigned to the light fixtures, like the lighting switches, depending on what do you need. Do you need a dimmer? Do you need a breaker or something like that? So you can say, you can do the circuiting for the light switch. All right. You can do the circuiting for the light fixtures, but the circuiting for the panel board that is required, you'll need to circuit the light fixtures too. All right. Does that make sense? Okay. So any questions on the panel board schedule till now? By the way, sir, did it answer your question for the panel board schedule that we were discussing yesterday? All. Now, sorry. Yes, it is possible. Click on the number of receptacles. Exactly. Number of fixtures. Okay. So it can be either done in the time code schedule. I would recommend to have a quantity takeoff for the circuits. Alright. So right now, yes, we can maybe take how much this is 500 VA and divide it by 500 VA to get the circuit that. But I would recommend to have a different takeoff for quantity takeoff. We can brush over that. I want to show you the lighting fixtures. So give me just a moment. We'll do the lighting fixture schedule as well. Okay. So this is the panel board schedule. We'll talk about the lighting fixture schedule. Yes. Okay. So let's go ahead and try to create now a lighting schedule as well. All right. So for creating a lighting schedule, what we'll do is in the project browser, scroll down where it shows schedule/quantities bracket all. Schedule/quantities all. Under there, right click and click on new schedule and quantities. Okay. One more time. Schedules and quantities. If you scroll down, right, you can even minimize the views option over here. In the schedules and quantities, right click on your mouse button and click on new schedule/quantities. All right. So now this will open up another window for you. All right. Right click schedule quantities, new schedule/quantities. All right. Okay. Now over here, when this particular window opens, in the categories, scroll down to the lighting fixtures and click on it. Lighting fixtures in the category. All right. And then hit OK. Now this will be the window that will open up for schedule properties. Okay. Yesterday we had tagged the light fixtures A and B, correct? So of course we require the type mark for it. The A and B where we had entered for the light fixtures yesterday, right? This one we had entered it as B, and the type mark that we had was B, right? This one type mark I think so was A. Yeah, A, correct. A over here, right? So that is the type mark we have for a given light fixture to make sure it is uniquely identified on the schedule. Right? Now, right click, new schedule quantities, scroll down, and you will have the lighting fixtures. Click on OK. It will open up this one. Now Revit is asking us, what all parameters do you require in your given light fixture schedules? First and foremost, we require the type mark by which we will identify it, right? Then, of course, we would require the load or the wattage. Let's check what option we had. We had the wattage, right? If you need the manufacturer make and model number, you can also insert that. Let's check if we have the voltages as well. Is there a voltage? The voltage loss. Okay, we'll talk about voltage in a minute, but let's make sure we have these four properties selected: type mark, Let's bring it into the schedule. This is available fields. What all information you can put in your schedule. And then on the right hand side, when you click on the green button over here, this is what you have planned to bring on your lighting fixture schedule. Click on that particular available property and then click on add parameters to add it into your schedule. Everyone with me till now? No? You want me to repeat it? Yes? All right. Right click, new schedule quantities, lighting fixtures, hit OK. It will give you the option of schedule properties. These are all of the properties that you can include in your schedule for the light fixtures. Scroll down over here, try to find type mark. Once you click on the type mark, then click on add parameters, the green symbol over here that is pointing the right way. Click on it, the type mark will come into your schedule fields. Next, we'll add the wattage. Select the wattage. Click on the wattage and click on add parameters. All right. Next, manufacturer will add and the model number will add. So far, so good. All right. Then once you are done with that, hit OK. Now this is the particular lighting fixture schedule that you have created. Right? But if you see over here, you have A, you have B, and it has itemized every. But if you take a typical light fixture schedule, A will have just one row, B will just have one row, C will just have one row, right? For that, what we need to do is we need to change some of the information here, right? So with your lighting fixture schedule open, in the properties, click on filter over. All right? In the filter, you'll have the sorting and grouping over here on the top. Sorting and grouping. Either you can click on sorting and grouping over here and then come to sorting and grouping, but we want the sorting and grouping tab open. Everyone with me till now? And in the sorting and grouping, you have the itemized every instance checked. Click on uncheck for it and hit OK so that you have only one line showing up. What happened over here? Okay, sorry. So going back, you also need to have some kind of filter associated with the sorting. So in here, make sure we have the sorting done by the type mark. Is it A? Is it B? So make sure you have the type mark selected over here. In the sorting and grouping tab over here. And once you have that selected, uncheck the itemized every instance and then hit OK. You will just have the type A, type B. All right. Now over here, you can go ahead and type out, or if it is already in there, then you don't have to worry about. Let's say this is a Philips light fixture. What this window is telling me that if I change it over here, it will be changed in the edit type for all of the type A light fixtures. Hit OK over here. And let's say the model number, we will talk it out as ABC. All right. Now, the second one, let's say it is Lithuania light fixtures. The manufacturer, and let's say the model number is XYZ. All right. So this is your lighting fixture schedule. When the manufacturer, when the contractor is looking at your drawings, he or she will look at the lighting fixture schedule and then order it as per the data that you have entered in the lighting fixture schedule. Everyone with me till now? There is one point you have selected wattage already. Okay, all right. Thanks for the update, please. All right. Everyone with me till now? All right. Let's so this kind of is coming to a conclusion for the electrical portion. Are we okay? Any questions on the electrical portion before I jump on to the plumbing portion? There is one point remaining, tagging. I'm going to take all the tagging together, since the tagging will stay, the concept will stay same, be it mechanical, electrical, plumbing. Everyone with me? Yes. No. All right. Coming back. Let's move on to the next section for our presentation. That is a plumbing section. That is on this one. All right. So yesterday we had spoken about the electrical systems, right? So right now we'll speak about the plumbing systems. If I can have everyone's attention, last home run, please, team. Plumbing systems. So typical plumbing systems found in a hospital, you'll have the wastewater piping system. What does that entail? It entails the sanitary soil or black piping system, right? The one that goes out of toilets, urinals, water closets, black water, wastewater, sanitary water, or even soil water sometimes, right? Those pipes. Next, it also encompasses the venting systems. You have a sanitary line, then you have a vent line that goes up, right? So that the methane gases in the sanitary lines do not build up and explode, right? In addition to that, making sure that the foul smell coming from the sewer does not come into the habitable area, right? Next, it is the domestic or potable water system, right? What is that? It is the cold water, hot water piping that we get through our faucets, shower heads, flush systems will have cold water, right? If you have a laundry in your given hospital, the cold water, hot water will be provided to the machines in the laundry, right? If you have a cafeteria and supported kitchen, you'll have the hot water, cold water going to those areas as well. And then we'll have the med gas piping as well, medical gas, right? Now let's talk about the typical plumbing systems or plumbing equipment that you will find in a given hospital. You'll have the water closets that will include both the accessible as well as the standard. Accessible are the ones that are capable of accommodating the special needs of a person maybe who is in a wheelchair, basically a handicapped person. Urinals, you will find it in the common restrooms. Lavatories, you will find for washing the hands in the restrooms. There will be kitchen sinks, as I mentioned. Along with that, there will also be laundry machines. Please note that this is like a overlap between the specialty consultant. In this case, it will be the laundry consultant if there is one, with the MEP consultant. All right, the laundry machine, because the laundry machine, we will not specify the laundry machine. We will only specify the connection to the laundry machine. All right. Next, talking about the different type of codes that you can refer to while designing these systems. For the wastewater piping system, you can base it on the International Plumbing Code, specifically talking about the specifically talking about the section 7 and table. We'll go through this as well of 709. Okay, there is point. Okay. So Grace, I know you mentioned some points. Give me some time. I'll come back to those points in some time. We are talking about the drainage fixture units regarding different types of drainage fixtures and how the units are associated with the drainage fixtures, how to calculate the sizing for the drainage fixtures. Next, talking about the sanitary piping as well. Once we have the connections to the drainage fixtures, how do we get the pipe sizing done? Next, the potable water. We will refer to the International Plumbing Code again, specifically the water supply fixture units, the potable water sizing, the potable water pipe sizing, right? Along with that, we'll also talk about the medical gas piping systems, technically talking about oxygen, nitrous oxide or oxygen mixture, the medical air, surgical air or nitrogen, vacuum, as well as helium and oxygen mixture. All right. So now let's go ahead and get into Revit and try to have some piping done for our plumbing fixtures. So if we are going back into the Revit, in the views, we will talk about the plumbing plans as well. Okay. We'll have the plumbing plans. So let's go ahead and open up the plumbing plan for the first floor. Right. In the first floor, as you see, there are different types of plumbing fixtures that are shown over here, right? We have the water closets, we have the sinks. These water closets are specifically focused towards accessibility for people who are handicapped, right? Then we will have plumbing fixtures in the general wards that we spoke about yesterday, right? Then we will have plumbing fixtures relating to any offices, right? So all of these need to be plumbed properly, right? Now, we'll talk about the International Plumbing Code. Let me get this on this one. All right. Once you click on the International Plumbing Code, we will talk about this link that we found. On the first day, we had spoken about the building code. Over here, we are talking about the International Plumbing Code. So if you can search for this International Plumbing Code on your system, and then try to find this particular chapter or section of the plumbing code over here, drainage fixture units, table 709.1 in section 7. So over here, please go to section 7. And in the 709 section, if you click on it, you will have the table number 709.1. All right. So this is the 709.1 table that we are talking about, right? So over here, this is what is giving us the load that must be considered for every plumbing fixture, all right? That has the sanitary water coming out of it, okay? So now we'll take a look at the floor plan and try to identify what type of plumbing fixture we have as compared to the table, right? Over here, we'll go one by one from left to right. Here you have a water closet, right? So if you check properly, if you try to tab and check on the architectural model, you see it is a water closet, and most probably it is a water closet with a flush tank. All right. Now, if you go back to the particular table over here, you will have the information regarding the different types of drainage fixture units. Okay. In this case, we will see there are water closets over here. All right. Toilets. Now they are considered in two different types. One is the flushometer for public or private. All right. In a flushometer water closet, you will not have a flush tank. You'll rather have a flush valve that will release the water with pressure so that the soil can be properly flushed out, right? Then we are talking about the water closet that is private, something like an office space where it will be only used by the doctor, all right? But when we are talking about the given plumbing fixture over here, that can be used by all of the occupants of the ward, all right? So that in turn becomes a public water closet. Do you understand the difference between both? Now, talking about what type of row we need to use. Do we need to use the 1.6 gallons per flush, or do we need to use 1.6 gallons per flush? Okay. Now this comes into picture when you're designing like a green building. If it is a LEED building, it will also push you to have systems such as low flow water fixtures assigned, specified for your project. And at that time, it will become that it is 1.6 gallons per flush will be the maximum that you can use. If it goes above that, then you will use this one. So now this is a conversation that you will have with the owner, with the doctors, as well as with any specialty consultant on how much of a plumbing fixture flush tank needs to be for the water closet. All right. In this case, what we are going to use with is the worst case scenario. All right. We'll assign the drainage fixture unit as 6 to the water closet over. This column will give you the drainage fixture units as load factors. So the load for the water closet will be 6. All right. So now if you go to the floor plan, this is a 6 DFU water closet. All right. This is a lavatory, right? Lavatories are the sinks in the restroom. So we'll try to find a lavatory over here. The load on a lavatory, the DFU on a lavatory is 1. All right. So now if we add, so now what we need to do is we need to add. If we start drawing a pipe from here, we need to understand how much big the pipe needs to be, right? So for that, we'll start counting the DFUs from this point and we'll try to get it to exit the building at this point. All right. So now we have DFU of 6 assigned to this one and DFU 1 assigned for the lavatory. A total of 7 DFUs. Is everyone with me till now? Okay. Next, what we will do is the next one for pipe sizing, we'll go to the table 710.1 of section 1. .1 of section 1. Now this section will give you basically the information regarding how big your pipe needs to be. All right. Yesterday we had a good discussion regarding the slopes that are required in sanitary pipes, right? You will need to confirm it with your building department. What is the slope you are requiring for a given pipe? Okay. As a safe bet, if you don't have a building department giving you this information, always try to have the slope of your sanitary pipe as 1/4 inch. What is that? For every 1 foot, your pipe will be sloped 1/4 inch. All right. If I can have I'll try to draw it on the screen as well. Share screen, documents, share. All right. So if you have a sanitary pipe starting from this location, okay, if you have your water closet over here, and looking at it from a section view, you will have the pipe coming out from here right? And then it will start being sloped. All right. So let's say from this point to this point, if the distance is 1 foot or 12 inches, the distance, right? There is a slope over here. So if I draw a line over here, this distance over here, I'll try to use a different color. This distance over here needs to be quarter inch. Make sense? So the slope of your pipe needs to be quarter inch. All right. Now, going back to the Revit model over here, what we'll do is, again, we'll try to have two views. One will be our floor plan. The other one will be the, yes. How to distinguish the extra? S-trap and P-trap. Okay, all right. So now the size you're talking about, or what type of an installation? Okay. So there are two ways of doing it. The question in-house was, how do we identify S-trap and P-trap for a given water closet, right? Okay. So there will be two options over here. If you check this particular water closet, I'll take a section over here so that we can check the section of the water closet. Okay. So over here, if you see, this water closet is a floor mount water closet, right? So when you have the, not model line, when you have the, pipe connected, it will usually come like this. This is how it will be connected in the water closet itself. All right. So this will be the S. All right. If it is mounted on a wall, all right. If it is mounted on a wall, usually there will be a carrier. It is called a carrier. Behind the water closet, there will be a carrier that will take care of the traps that you require in P-trap or S-trap. All right. So it depends on the availability of what is available in your market. If S-trap is available, P-trap is available. All right.
Sometimes I think there's not more
P-trap and S-trap. Yes. So is it usually the plumbing contractor who orders the plumbing equipment over here, or is it the general contractor that will order it? General contractor. Okay. So you need to coordinate with the architect who have a note on their floor plan that will call out the type of traps that is required.
Sometimes needs like an engine
that is correct. Yeah, that's what I'm saying. Exactly. So there are two aspects to this. One is the market availability of the type of equipment that there is, and then the location of that particular water closet. Is it floor mounted? Is it wall mounted? If it is a wall mounted, then you have a couple of options. If it is floor mount, most probably it's going to be S-trap. Does that make sense? All right. Going back to, what happened? Going back to Revit now. Now what we need to do is we need to start, that was the floor above. We need to start drawing the pipes for the water closet. Okay. One mistake that you see that the architect did over here was the placement. They don't have it on the vertical wall. They have it on the floor. All right. So this is very common. This keeps on happening. Coordinations keep on happening. If you come across this kind of issue, please bring it up to your architect so that he or she can have it properly given. All right. So let me share my screen. Sharing the right screen. Okay. Sorry about that, Lawrence and Tony. The point was regarding what type of connections do we use? Do we use a S-trap or a P-trap? So there are two types of water closet. Is it based on is it based on floor mount or is it based on wall mount? If it is floor mount, then the possibilities are that you have a S-trap assigned to it. If it is a wall mount, then it might be a S-trap or it might be a P-trap. You'll need to confirm that with what is available in the market and then specify it accordingly. All right, going on over here. Now that we have understood that it is a floor mount, it is a 6 DFU plumbing fixture. We'll go back to the code and try to identify the trap size that is required by the sections 7, table 709.1. Over here, as you see, you have the water closets noted over here, and the trap size, it is saying C note D. The note D basically says the trap size shall be consistent with the fixture outlet size. This is where the manufacturer will come into picture, and manufacturer will most probably have this trap size at 3 inches. All right. So what we'll do is we'll start going back to the section that we had over here. In the systems, we'll start creating pipes. All right. You have plumbing over here and you have pipe over here. All right. In the plumbing and pipes, make sure you have it selected to standard, and the system type over here, make sure you have it selected to sanitary. All right. Next, we'll start plumbing the equipment as required by the code. Now over here, you see we have taken a down over here, but we need to have a slope assigned to the pipe. The slope was 1/4 inch. So make sure you click on slopes down, drop down the box and select 1/4 inch equals 1/4 inch per 12 inches. And that is how you're sloping your pipe over here. Is that making sense till now? Well, one more point. We have not had a vent for this piping. All right. For that, I need to make sure that you have it shown as a try connection. Draw the pipe. Now this side we need to go slope up. We don't need to go slope down. So make sure you have slope up selected, and then you go slope up over here. Go a bit up, and then we will start drawing the pipes in the venting. Right now it was still sanitary. Make sure it is venting. One more point I missed out. Make sure you have the correct pipe type selected. Of course, the pipe type for sanitary lines will not be copper. It will be different material, most probably PVC or maybe cement as well. So in that case, if you are given with that option, go to edit type. Systems. Let's create a duplicate one over here, and this one. In here, you will have the properties for the material that you can select it and make it what you require. In this case, we'll try to check if there is a PVC. Over here, PVC rigid is what we will use, and we will change the type of the light plumbing fixtures from the systems to sanitary 2 because that is what we require over here. So now we have the proper given material assigned to it, which is the PVC. Is everyone with me till now? Online? Now, talking about this particular lavatory over here. Now this particular lavatory needs to be on the wall actually. So over here, what I'll do is I'll create another section, go to view, and then what I'll do is I'll start drawing the pipe from the wall over here. Now the pipe will come down. Again, it will be sloped down at a 1/4 inch slope. Oops, is it quarter? No, it's not quarter. Draw pipe, slope down, and now we have it at the 1/4 inch. This is at vent. We'll change it to a sanitary system. All right. And now as you see, in the other section, we are noticing that the pipes are not properly coordinated. So what we'll do is we'll align the pipes so that they are coordinated now, right? Now, as you see on the floor plan, we are not able to see the pipes, right? That is because our view depth is not properly assigned. For making sure that the view depth is properly assigned, we'll go to the view range, select the plumbing floor plan, go to the view range and click edit over here. Once you click edit, you will have this particular window that will show up. All right. Right now, the view depth is at 0 feet. What we'll do is we'll try to make it -2 feet. All right. Once you change the view depth, now you'll see the pipes showing up. But we still don't have this pipe showing up, right? As we drew it over here, we still don't see this pipe. Okay, it's visible, but it's overlapped with the section. All right. Now what we'll try to do is we'll try to connect the two pipes to each other. All right. For that, we need to make sure that we have the elevations of the pipe properly coordinated. Try to make it come to the same level and then try to draw the pipes for connection. All right. Now that the pipes are connected with a T, the sanitary will never go in a T. It will go in a Y. All right. So over here, drop down the box and click on T for sanitary. So what we'll do is we'll change the routing preference over here and the transition. Make it a sanitary. So over here, when we click it, it will make it a Y joint. All right, not a T, a Y, so that the solids can move without obstruction. Now going back to that table that we had for section 710A over here. Now, what this is saying is at a 1/4 inch slope, if your DFUs are 3, you can assign a 1.5 inch pipe size. All right. But now we see that our pipes, the total DFUs was 6 + 1, 7. Right. That is greater than 3, which falls in the 2-inch diameter category. Okay. But when you have a water closet, all right. When you have a water closet, the manufacturer will 99% time have you specify 3-inch connection to it. All right. It generally tends to be that water closet connections are 3-inch or above. All right. So if you begin with a bigger pipe diameter in plumbing, you cannot reduce it. You have to keep on increasing it. If you reduce it, the chances of the soil getting stuck and over pressurization comes into picture. So whenever you have pipe size going in a plumbing system, it keeps on going bigger. Is that understood? Now we start with a 3-inch from here. So right now we had it at 6 inch, which is an overkill. We now need it at 3 inch. So we'll change the size for these from 6 inch to a 3 inch. So this one. Now this will become a 3 inch. Okay. On the other side, if you look at the section, now that was for the water closets. Now if you look at the section 709, for the lavatories, what they call it is a minimum trap size of 1¼ inch. All right. So the pipe coming from the lavatory will be 1¼ size over. 1¼ all right, and then it can upsize over here at this location. So this came in at 1¼ inch, and then it upsized to a 3. It needs to upsize, it cannot downsize for a sanitary. Does that make sense? Now what we will do is we will keep on extending this line up to this point, and then we will draw a pipe and take it all the way back to this particular section where we have the water closets. Okay. When we are doing a turn in a given plumbing system for sanitary, always make sure you have a clean out. If it goes a 90 degree, make sure it has a clean out. What that clean out is basically is, just a minute, I'll come to your point. So I've made a Y joint over here. I've sloped it up over here. And now I'll go to the section view. And then bring a pipe up so that you can have a floor clean out for the given pipe. All right. What is a clean out? Basically, if the pipe is turning at an angle and there is clog somewhere in that angle, this clean out that is in the floor will be required to use pressure systems to push the soil in the pipe and making the pipe clear. Okay, your question. Long radius fitting. Sure. Well, code will push for a floor clean out or a wall clean out if there is no floor space available, so that the floor clean out can be opened and a probe can be sent through. Again, if you're turning throughout the life of that pipe, the impurities, the soil will keep on getting accumulated in that long radius elbow as well. But there is no way of cleaning it then, right? How do you clean it? Do you remove it? You cannot remove it in operation, right? So for that reason, you need to use the clean out. All right. So let me show you what a floor clean out will typically look like. So when you see it from the ground up, the floor cleanouts will look something like this. Okay, something like this. That the probe can be sent through here and checked through here. So what we are looking over here is basically that. If you check the section over here, this is the floor cleanout for the radius, for the turn that this pipe is making over here. For the turn that this pipe is making it. Make sense? All right. Now, we have 7 DFUs till this point, correct? Are you everyone following me? Now, our pipe is going to make one more turn to make it go from the outside. Now we'll slope it back down and we'll put it outside over here. Okay. Now it gave me an error saying that none of the elements are visible because of some kind of parameters or view settings. Now you remember we put a different depth for viewing, right? What has happened is that the pipe has went below that depth because we are sloping the pipe, right? Make sense? So what we need to do is we need to go to the floor plan. We need to change the view range and let's make it -5 foot so that all of the pipes can show up properly. We are sloping the pipe, right? It started maybe at 1 foot, but right now it is 4 foot because it is being sloped throughout, right? Now again, over here, we are taking a turn over here. So we need to have a clean out. So we'll make it a three outlet connection with a Y. And then we will make sure that we have the clean out that will be coming up. So right click, slope up, and then it is coming out. All right. So now on the floor plan, this is another of your clean out. Okay. Just make sure that this connection is going the right way. We don't want it to come this way, right? The soil is flowing this way. The wastewater is flowing this way. All right. Now still we have 7 DFUs over here, right? Now, if you add this, how much DFUs one water closet we had? 6, right? So now 7 plus 6. The total DFUs after picking up the soil from this will be a total of 13. Making sense till now? All right. So now going back to that section over here, right? So this pipe is right now at 3 inches. We'll go back to the code and try to check what the code says regarding a DFU load of 13. 13 still can go up. Right now we are at 3 inches, which can go up to a total DFU load of 42. Since we are below 42, we are doing good. Okay? Now, we'll count one by one and try to check where, if necessary, the pipe size will change. Okay? So if we connect this line and this line over here, so that will be 7 plus 6 plus 6. Right? Let me take out my calculator. So now 7 plus 6 plus 6. We are at 19. We are still doing good, right? Now again 6 plus 6. Adding to the 19, total of 12, we are 31. Our limit for 3 inch was 42, correct? Next. Now we have one water closet, and let's say we are connecting all of these together and we are connecting it over here. So one water closet comes over here. So now 31 plus only 6 from this side, but lavatory is 1, correct? So that will be another 1 coming up, making it 38. All right. Now this one is also coming in, which makes it a plus 6. We are 44. Before you pick up this water closet pipe over here, your pipe size should increase to a 4 inch. Is everyone following? Yes? No? Or going out of coverage area? Yes? All right. So basically the same concept that we are applying for CFM when we are doing the duct sizing, we are doing it over here. CFM, as we go from the source to the last point, the duct size will keep on reducing. On the other hand, when we have the drainage fixture units, the pipe size from the last point to the utility connection point will keep on increasing for the drainage size. If it is for water size, it will keep on reducing from the source, that is your water heater or utility connection, all the way up to the last point. So we'll talk about that as well in a minute. Make sense till now? So now, before picking up over here anything, we need to have a size change. So we'll split the pipe at that location, the same way we had split the duct, and we will change the size from 3" to a 4". All right. Now if we see, we'll start drawing the pipes over here. So we can draw a pipe sloping up at 1/4" to this one. Then the same one we can have it. Oops, not correct. So draw pipe. Then what we will do is we will inherit elevation. So basically what elevation we are connecting it to at this point of time, since the pipe is tilted, we are going to inherit that location in 3D coordinates. Okay. And then we will slope it up because from here the loads are going down, right? So we'll click over here and we'll come over here. So now if you see properly, the loads are coming like this and going this way. All right. What we can do is we can bring the other point, other system from here, and then come down from here and then get it connected over here. Okay. Just be careful. This is something inbuilt with Revit. If you have this kind of connection, you have a 2-point connection, 2Y connection, double Y connection, the elevation will be a bit hard for you to inherit because there is one Y connection and you're trying to tilt it at one location. It might give you some issues. I have had conversation with Revit folks and this is something that they are working on. It is still something that is being worked on. But one point is there that we need to have a double Y connection. This is not a Y connection. This is a regular cross connection. So what we'll try to do is we'll try to change the routing preference. Here we'll try to make it, okay, that connection is not loaded, looks like it. Just give me a moment. We'll go to insert ribbon, load as a group. Oops, no. Or load Autodesk family over here. If I go a bit more, that will be fine, right? Maybe 15-20 minutes because there are questions online as well that I want to confirm. So over here, okay, so I'll give you an idea what that looks like, and there is a family for it as well. It is called the double Y connection. But what that will look like is something like this. Okay, so you will have two pipes coming at one location and then going down. All right. Right now, what we have is a Y connection that was shown over here. So this is the connection that we are trying to show in Revit right now over here. This one is a Y connection. All right. What we were showing over here in the previous one is a double Y connection. All right. This one or this one, very common in sanitary systems. But I was trying to simulate that over here. You can try to find out the double Y connection in Autodesk Revit as a family. But over here, what I'll simulate over here is drop pipe and then slope up for this particular plumbing fixture. Now this is the same issue I was saying. The thing is, at this point we have the slope coming up from one inherent elevation. So if you go into the section view, you already have that connection which is sloping down. When we are going on the right hand side, we are trying to slope it up to go to the plumbing fixture over here. So it will go up over here. Now the fitting is already tilted and you're trying to make it go the other way. That is where the issue is coming from. All right. This is something inherent to Autodesk that will be hopefully resolved soon. But for avoiding that kind of issues, what I suggest you doing is have an offset between your connections so that you don't have to use a double Y joint. Okay. So if you have an offset for this particular pipe over here, then you can have another pipe that you can draw at a 3-inch with an inherent elevation sloping up from this point over. Okay. So this is the offset that I'm talking about. Make sense? Okay. Now you'll have the same connections coming from here, 1 inch coming from here, 3-inch coming from here. But when you're taking care of all of these plumbing fixtures over here, right? What I had mentioned was we'll club these all together. Okay. So each lavatory is 1 DFU. So the pipe that is connecting to all of these will be a total of 6 DFUs. Now when we are talking about 6 DFUs, then we are talking about a minimum size of 2 inch for the pipe. Make sense? So now what we are talking about in Revit over here is we'll make the pipe that will be a 2 inch. Right? First it will be in a wall, because usually what ends up happening for back-to-back water closet is, of course, this water closet needs to be up, but what you'll need to have is the water closets will have a P-trap coming like this and then going into the wall. All right. The same thing will happen on this side as well. It will have a P-trap and then going into the wall. So the wall over here will contain that pipe where the P-traps are connected. All right. Now that pipe needs to be somewhere over here under the sink. Right. So in that case, what we'll do is we'll take another section and move it to that particular location. So this one, we'll move it over here. And then we'll start drawing a pipe over here, which let's say somewhere around here. But again, we need to slope it down at 1/4 inch. And then we are dropping it down so that it can go to the particular point. Yes. In the wall. Okay. Wall, right? Okay. So the question in-house was sometimes the civil engineers will discourage us as plumbing consultants to have the pipes in the wall. They would prefer having it on the surface of the wall rather than in the wall. The say of what I'm trying to do over here, like this pipe, I'm trying to simulate it in the wall instead of on the surface of the wall, right? In that case, it is fine. You can have it on the surface of the wall, but push the architect to have some kind of casework below this particular plumbing fixtures. Yes, some kind of casework below it so that people will not bump into that plumbing fixtures, or it will not be readily accessible to the pipes, or not plumbing fixture, to the pipes. It is fine, right? Just make sure you coordinate that with the architect. And the best case for us is to have a small chase that can have all the pipes go through it. Best case, all right? But best case seldom happens. I'm aware of that, all right? Now, talking about the pipes, now it drops down over here. Again, we need to connect the pipe. It is a 2-inch pipe and it needs to be connected over here. All right. Again, I will inherit elevation. I will slope it up to this point. All right. I'll make sure that the pipes are properly aligned. So modify, align tool over here. It is with this point that we need to align our pipe. Looks like the pipe, what happened? So the pipes will try to align it with the pipe over here. So annotate detail line over here. Just for reference, we will have this line and then we will move our pipe to match that particular reference line. Now what we'll do is we'll try to go to the section view and then we'll bring down our pipe. When we bring down our pipe from the wall, you see Revit has already identified the slope. Right now there is a slope to the pipe. So you can straight away bring the slope and get it connected. Now our lavatories are also connected. Does that make sense? So now if we go to the floor plan, when we connect this will also come in at 3-inch, but this will be 4-inch. All right. Please note, we have not considered these plumbing fixtures over here. I was going right to the last one, but these plumbing fixtures also will come and connect to the pipes. So I've shown you how to calculate the DFUs properly. It's the same way. You'll need to calculate the DFUs of this line, and most probably it's going to be a 3-inch because there is just one water closet and piping over here. So 3-inch connecting to a 3-inch, it is fine, but make sure that the DFUs are properly calculated. Making sense till now? All right. So yes. Okay. So till now, everyone with me? Yes? All right. Let's have a chat regarding the next one, that is the potable water. Okay. So for just like we have a drainage fixture unit assigned with a sanitary aspect of a plumbing fixture, you will have a water supply fixture unit, WSFU, assigned with the hot and cold water aspect of a given plumbing fixture. All right. So what that is basically in Appendix E of the International Plumbing Code. You scroll down, you'll have an Appendix E over here. All right. In the Appendix E, please go to E103.32 for checking what your WSFUs should be. So over here, just like we had the DFUs, drainage fixture units, we have the WSFUs, water supply fixture units. All right. Just like we had water closets, publics and private, we have it over here as well. Okay. If you have a flush tank, you will use this particular row if your water closet is in a private setting. All right. But if it is in a public setting, then we need to use the water closet public flush tank, which has a 5 water supply fixture unit. All right. 5 on the water supply fixture unit. And if you have hot water systems, you will use this column over. This column is for the cold water, cold potable water, and this column is for the hot water. Make sense? So now talking about the water closet 5 over here, right? So this particular water closet that you have will have a water supply fixture unit of 5. Okay, DFU is different, WSFU is different. Okay, so you will have one cold water line coming to this particular flush tank. Okay, sometimes it comes from top, sometimes it comes from the bottom if it is pressurized, but make sure you have it properly coordinated. All right. Now Going into the section view, we'll start drawing it from the top or from here. Okay, so over here we will have a pipe coming from the top and going into the flush tank. All right, so for that we need a WSFU of 5, but what is the size that we need? Okay, we need a size as well for it. So for that, what we will do is we'll use this link over here. You can just simply go to engineering toolbox and type in WSFUs. You'll have this first link coming up. Okay, WSFUs engineering toolbox. This graph that I'm going to show you is also available in the IPC somewhere, but I was not able to find the proper location of it. But basically, this is what we are talking about. The water closet that will have a gravity flush tank will be 1/2 inch in size. All right. So what we will do is we'll start drawing the pipe. We'll go to systems. We'll go to pipes. In the pipes over here where we had the sanitary, make sure you have domestic cold water. And then over here we will have the diameter of the pipe supposed to be 2 inches. Okay, so usually there is a valve down over here, so we'll start drawing from here and we'll go up into the ceiling and then we'll run it into the ceiling. Now if you understand over here, Revit defaulted to the previous setting and it automatically gave me a slope, but cold water, potable water does not require a slope. All right, they can go straight. So you can click on no for the slope and you can bring it outside. Now we know there is a given lavatory over here. All right, so that lavatory, if we check what is the given size for it, so let's try to check a bathroom lavatory or something similar to that. Laundry sink, kitchen sink, bar sink, lavatory is 1/2 inch. All right, so now that also will need to be modeled in our given project at 1/2 inch. So we'll move this section from this point to this point, and then we'll go to the section. All right, over here this is the pipe that we had coming up, right? It's supplied to the water closet. Again, this pipe got drawn at the exact center position where I had the section and we were looking at it from the section view, right? So let's make sure that we have it properly coordinated, because we do have a window, so we cannot drop the pipe directly through the window. So what we will do is we'll delete a small segment of it and we will rotate the given elbow to make sure it goes that way. And then we'll start drawing the pipe so that it comes near the water closet, right? So there will be a wall over here which will have a flexible connection to the given flush tank. All right, over here we will require another pipe coming down. The pipe will come down from here for the water for the lavatory. Okay, and then we will take it up and we'll try to match the elevation with the align tool in the modify option over here. Okay, so now this point and this point is aligned. Now we'll go to the floor plan and check what is going on. So in the floor plan, again, this is the pipe that has been drawn, right? But again, it is not properly centered. So we'll make sure, and even the sanitary line is not properly centered. So we'll click on align. We'll check the center line of the lavatory as the reference, and then we will move our the sanitary line to be centered for the lavatory. All right. Same way, you can even do that, but usually what ends up happening is, again, there are walls below the water closet or the sinks where the cold water connection will go. All right, so we'll move this pipe to be a bit of offset with the lavatory. Now over here we'll connect it to the pipe. All right, Now what is happening is it has taken a Y connection over here as well. But there is no need for a Y connection in a given cold water line. It can be a T directly because there is no suspended solids that are going to get problematic. So you can go ahead and select a, what is going on here? Looks like the edit type routing preferences are set to sanitary. This can be generic. Okay. We will delete and we'll draw it again. Okay. So now it is a T joint. All right. Now again, we are looking at the WSFUs over here from this point, right? The water closet has a WSFU of 5. The lavatory has a WSFU of 1.5. So 5 plus 1.5 is 6.5. All right. Now we need to check, just like we had a table for making sure of the sizing of the sanitary lines done properly. Over here we have a graph that we can refer to. So over here, what we will search for is WSFU GPM. Engineering Toolbox, WSFU GPM, which will take us to this particular link over here. And if you scroll down, you'll come across this chart. All right. Now in this chart, what we are seeing is in the bottom over here, there are two charts. First of all, this one is kind of an enlarged view of this particular chart. All right. So now we are looking at how much WSFUs at this point, 5 plus 1.5, 6.5, right? So if you go to your graph over here and try to plot 6.5, right? So 6.5 will fall somewhere over here, which is coming up to around 18 gallons per minute, something like that, right? Now over here we take the conversion. All right, over here we take the conversion. So 6.5 will make sure the 18.5 that we were talking about will go up to 7 WSFUs, right? Now half inch plus half inch. Now we need to add up one by one all the WSFUs to make sure our sizing is done properly. Similarly, we had done it for DFUs, right? So now let's go to Engineering Toolbox and okay, over here, as we see, we have the water supply fixture units and the gallon per minute that we had calculated from the graph. And then I'm trying to size the, okay, this is where we will come for the given sizing of the given proper total WSFUs. So 6.5 comes under this, and we want to keep our pressure drop below 0.1. All right. So if we are going to 0.1, we'll need to have a 1 1/4 inch upsize over there. So from a half inch, we are upsizing it to 1 1/4 over here. So over here, before it picks up, the size of the pipe requires to be 1 1/4. So anything after this will be 1 1/4. So a total of 6 DFUs are carried by this particular cold water line. Now it splits with 1.5 going over here, right? And the rest of the 5 DFUs going on this side. Does that make sense? I know I'm talking a lot. Please give me a feedback over here. I'm going, yes, it has. I'll teach for the hot water as well. Okay. Same way, right? Now, going back to our table for sizing, right? Potable water E103.3. Okay. So E103.32, right? Now over here, just like a cold water WSF use, you have a hot water WSF use, right? Water closets will not get hot water. They will only get cold water, correct? Now that hot water that we are looking for laboratory, that is a public one, that is still 1.5. 1.5 will correspond with again half inch that we are talking, right? Now we will draw a pipe for a hot water in parallel to the cold water over here. So again, we are going to systems. We are drawing the pipe, and over here we want a hot water pipe. All right. And again, it is a half inch hot water pipe that we are sending for the water lavatory. No hot water for the water closet. Over here, this is where we will turn to go in parallel with the cold water. Make sense? Now, the next one that comes up is over here, the hot water line, right? So we'll start to draw the same line from this one in parallel to the cold water line, right? We'll go in parallel so that it is easier for the contractor to follow as well. So we'll go all the way back over here. And then we have this particular pipe as well that will bring till here, right? So now over here, we have this particular lavatory and this particular water closet, right? So now water closet WSF use 5, this one 1.5, right? 5 plus 1.5 plus 5 over here plus 1.5. So 6.5 plus 6.5, 13, right? So at this point, what the cold water line needs to be sized for is 13 WSFUs. Over here, the hot water WSFU is 1.5. Over here, hot water WSFU 1.5. So a total of 3 WSFUs that we are talking about, right? So what the hot water line will be sized for is 3 WSFUs. Make sense? So now, let's move this section as well. On this side, go to that same section that we had. Again, we have the lavatory down, but it doesn't need to be down. So over here, you have the, first we'll draw the hot water, that is fine. And then we'll go to the floor plan, and then we'll try to draw the cold water as well. Not done. Fine. We'll have a cold water pipe as well. We go back over here. And then you will have these pipes joining to the main pipes that we have. Before doing that, we'll also make sure that we have a T for the water closet. right? Because that one also requires a cold water line. And we had seen 5 plus 1.5, we need to be at 1 and 1/4 inch size over here, right? But this one will stay as is, right? And then we can bring up this one to this one. We'll not connect it. We'll make sure that we have it properly coordinated. Okay. Now, this is a classic example of coordination. As you see, if I can have your attention, as you can see, my pipes are going through my ducts. All right. Why did this happen? Because I did not check the section at that time when I was drawing the pipes. All right. So what we will do is we'll move these two pipes out of the ducts, the main pipes out of the ducts. All right. Now your plumbing is coordinated with your HVAC as well. All right. Again, we'll try to align both of the pipes, this one and this one. And since we are coming to the connection over here, we'll make the connection for the cold water over here. Are you guys following till now? Sure. Please give me a feedback online as well. And over here, this hot water as well, we'll get it coordinated. The hot water right now, as you see, if I come directly in the same level as this one, this pipe, it will be in conflict. So what we'll do is we will get it up and get it down back again. All right. Since the cold water and hot water lines are pressurized, it is fine if we go up and down and then get it connected to this pipe. Does that make sense? Okay. Any questions till now on the cold water and hot water? Gorky, 2 minutes. Just 2 minutes. I'll come up, sir. I'll come up, sir. 2 minutes. Yes. Okay. Okay, there was one point from Lawrence. I think for every sanitary with both hot and cold is always on the right while hotline is on the left. Yes. So you're correct, Lawrence. I had it mixed. When you have hot water, it is always on the left side. If you have a hot water and cold water line coming to a plumbing fixture, left one will always be hot water and right one will always be cold water. All right, as per the industry standards. All right, so I know I have more points to cover. Right now we are at 1:30 p.m. Kigali time. I know regarding doubts from Grace, you mentioned you wanted to learn regarding regarding the ambient task, emergency, energy efficient lighting. Okay. Some more topics that you mentioned were regarding the cable management with the electrical as well as mechanical. Sure. And then Tony mentioned regarding firefighting. Tony, firefighting was not a part of the curriculum. So firefighting, maybe we'll keep it for another course. But for Medgas is also one point that is pending till now. What I have asked the Nziza staff is get in touch with you, with all of you, to make sure that we have those points covered maybe next week, maybe through online online that I'll be coming online. Okay. So right now I'm going to halt over here, conclude over here the session for today. But we will have some more topics, specifically those 3 topics that we will get it covered by next week as well. Right. So I'll hand it over to Emmanuel.
So, as we are approaching our end of this seminar, there is one question left from the online folks. So, Mr. Tejesh, you have one question to answer from those who are attending online.
Okay, there is a question from Grace regarding single line diagram schematics can be done on Revit. Yes, it can be done. I'll do one thing, I'll include it in the rest of the session that I still need to take. Next week, the Nziza staff will get in touch with you. We'll go over those as well. That time, I'll make sure I copy your questions so that I don't miss out. There is a transcript as well that will be coming, right? The questions that they are asking, there will be a transcript as well that we'll be getting, right? The chat. So that you can send it to me, and next time I present, I can answer it. Yes, right? That chat output file will come, right? Text file. Yes or no? That's a question. Yes, got it. Perfect. Thanks.
Yes, engineers. As we come to the end of this seminar, I want to take a moment to sincerely thank each and everyone for his or her participation and engagement in this seminar for MEP Design Expert Seminar. So for those who are online, the questions that you have been asking, Mr. Tejesh have said that those questions will be answered to our next or our upcoming session, which may be held on the next week by using the online way. So we will inform you about that session, and those questions will be answered in that session. So we are on the end of this session. That's why I want to once again thank for your attendance and your participation. For those who are attending physically, we are going to move from here to Hotel Saint Famille, where you will be handed with your certificates for attending and completing this seminar for MEP design. And for those who are online, you will receive your certificate through the emails or through the Autodesk system. So again, thank you so much. Thank you. But remember that the skills or what you have covered today will not only enhance your professional growth, but also inspire to apply these new skills in your respective fields. Thank you. Have a good day.